In this video, let's see the various applications of matrices in real life. The matrix was introduced by Arthur Kelly in the year 1858. Matrix is a Latin word. Matrix is nothing but a value with many rows and columns, and that system is used to solve simultaneous equations and other applications. There are many applications using matrices. Here let us see a few main applications. Google search. When you're trying to find the web page, and if you are trying to rank the pages, how it is visible when you are searching for a web page, that involves matrix applications. In cryptography, when you're converting, encoding or decoding messages, sending from one end to the other, in order to have secrecy, you use cryptography. You convert, you decode or encode the messages and transfer that from one end to the other. So there we use cryptography. In the case of regression analysis, when you're trying to find the line of best fit, or the method of least square analysis, when you're trying to find a relationship between two variables or three variables, whether it is a linear relationship or quadratic relationship or exponential relationship or whatever it is. Mainly when you're trying to find the interpolation and extrapolation values, we use the regression analysis. In data analytics, we use matrices when you're trying to gather information and collect plot values and all that. In physics, we use matrix, especially when you're trying to solve problems involving voltage and current, mainly using Kirchoff's law. When you're trying to solve for voltages and current, we use matrix applications. We use stochastic matrices when you're doing business models. In geology also, we use matrices. In matrix calculus, we use matrix often. That is why matrix is widely used in calculus. When you're plotting real-world data, there again you are using matrices. In economics related problems, especially when you're trying to find the GDP, you use matrices. In data analytics, you use matrices. When you're trying to change the movements of robots and automation, you use matrices. A vector will be set and then you can change the movement of the robots in that direction, in any direction you want. Let's take physics. In physics, matrices are used in electrical circuits, quantum mechanics, and optics. It is mainly used in calculating the battery power outputs and especially in solving problems using Kirchoff's law, using voltage, matrices, etc. In Google search, matrices are used, especially when you are trying to rank the web pages. Stochastic matrices and eigenvector values are used in order to get maximum input in ranking the web pages. In cryptography, when you want to convert the messages or code the messages, you use matrices. Matrices and the inverse of those matrices are used by programmers for coding or encrypting a message. In geology, when they are trying to find the seismic survey, they use matrices. Matrices are used for plotting graphs, statistics, and scientific studies in geology. In economics, when they are trying to find the GDP, there they use matrices. They are using matrices to have the goods production efficiently. When they are trying to find the movements of the robots, the robotics and automation, matrices are used. See, they fix a line as a vector and they try to adjust the vector such that the direction or the movement or the frequency of the robots will be changed. In data analysis, matrices are used. In matrix calculus, it is widely used, whether it is a two-dimensional, three-dimensional, or nth dimension, whether it is a direct derivative, partial derivative, whether it is Laplace transformation, any transformation, you use matrices quite often. So in this video, we saw various applications of matrices, and this emphasizes the importance of this topic, matrices, in linear algebra. Matrices plays the main role in most of the real-life applications currently, and enjoy learning this new topic, matrices. Thank you for listening and thank you for watching this video. Thank you.